Hello everyone, good morning one and all, respected Vice Chancellor, Kalinga University, respected Pro VC, respected Principals, Director, respected HOD and all dignitaries, faculty members of Computer Science and Engineering Department. I am Sanmati Kumar Jain, PhD scholar in Computer Science and Engineering under the supervision of Dr. Rajesh Keshrao Deshmukh, Department of Computer Science and Engineering. Now, my research topic is a study for design and development of model by automated machine learning and deep learning techniques for classifying diabetes mellitus. Now the structure or content or indexing of the today's presentation on my research topic: introduction, review of literature, research methodology, result analysis and interpretation, conclusion and suggestion, and references. Now let's start with the introduction of my project. Diabetes mellitus is an global health issue, and accurate diagnosis is essential for timely treatment and better patient care. This project focuses on developing an advanced model using automated machine learning and deep learning to improve the classification and prediction of diabetes. By leveraging AI, the model aims to enhance diagnostic accuracy and support healthcare professionals in making informed decision. Now, the key concept of the introduction: AutoML. What is AutoML? AutoML automates the process of building machine learning models. Deep learning mimics the human brain to find complex pattern in medical data. AI in healthcare helps in faster, more accurate diabetes diagnosis. Now, the statement of M said that the study seeks to harness the power of these advanced methodology to build an accurate, scalable and efficient model that can facilitate early detection and diagnosis of diabetes. By integrating automation in the machine learning process, the study aims to streamline the model development, reduce human intervention, and also enhance the model's predictive performance, thereby contributing to improve patient care and management. The main aim of the statement is said that a study for design and development of model by automated machine learning and deep learning techniques for classifying diabetes mellitus. Now, why need of this study? First, this is the important point to know: why need of this study? Diabetes is a leading cause of severe health complications in a worldwide. Early and accurate diagnosis can help to prevent serious conditions like heart disease, kidney failure and vision loss. Traditional method also available, but traditional method requires significant expertise and time, while AI driven model can offer fast and precise diagnosis. And further, after the my study, further scope of the study, the model will be trained on medical dataset to identify diabetes risk factor. It will integrate AutoML to make the model accessible even to non-expert. The project has potential application in hospital, clinics and healthcare research. Now, following are the main objective of the study: to discuss about AutoML, to discuss about machine learning and the process deep learning techniques applied to medical diagnosis, a focus on diabetes mellitus. This is the main objective of the study, to identify and gather diverse data set containing clinical, genetic and lifestyle data relevant to diabetes mellitus, to design and implement automated machine learning pipeline to explore and compare various type of algorithm, decision tree, ensemble method for diabetes classification. More focuses on diabetes classification by using AutoML model, because the classification, most of the people in this world are patient of diabetes, but they don't know which type of diabetes he have. So this is main requirement of the model and main requirement of the present scenario. The classification may be more accurate and clear. To design deep learning model to diagnosis of diabetic retinopathy, means that out of 100, 30% of the people who have diabetic they have the problem of retinopathy. So we include this is on focus study in the my objective, to propose recommendation for effective implementation of AI driven diagnostic tool in healthcare setting. Now what is machine learning? First of all, we need to require a study of the machine learning. Machine learning, what is machine learning? Machine learning is a subset of the explanation or subset of the artificial intelligence that involves the development of algorithm and statistical model that computer system use to perform a specific task without explicit instructions. Instead, these systems learn and improve from experience data automatically. Now the machine learning and deep learning. Now the deep learning is a specialized subset of machine learning, means that if we can say what is the artificial intelligence, and artificial intelligence is become by the two subset, machine learning and deep learning. Deep learning is the subset of machine learning and machine learning is the subset of artificial intelligence. So two subset can implies on artificial intelligence. These deep learning algorithm inspired by the structure, exactly the structure and function of human brain, known as a artificial neural network. Means that in this diagram we can see that complications and complex network are complex veins are complexity can be solved by layer to layer. Means that in human brain many layers are stable and in the human brain. So in the deep learning also, this neural network consists of many layers, hence deep means deep, this name suggested deep, hence that name, that enable the learning of representation of data with multiple level of abstraction. Deep learning has proven highly effective in tasks such as image and speech recognition, natural language processing and medical diagnosis. Now the automated machine learning, we have studied in deep with machine learning, deep learning, and now we imply the automated machine learning. The diagram, traditional machine learning workflow and auto machine learning workflow. Diagram and flow of the work of traditional machine learning and AutoML workflow is also classified in the flow. So this is the traditional ML, define problem, evaluate, means that they run that define problem, collect data, pre-process data, train model and evaluate. Now then again define model, collect data, pre-process. This is the sometime manual process we need to require in a traditional model, but AutoML, once we train the data, auto machine learning which get the data and auto trained. This data is auto trained in by the experiencing, means that studied the experience, what experience said that according to experience and predicted data set, the machine learning model will be auto trained, and this auto trained model will work AutoML. This is called auto machine learning, means that automatically chosen the best machine learning model for the task, hyperparameter tuning, adjust model setting to improve accuracy, feature engineering, select and transform the best data for training. This is the automated machine learning model. Now, diabetes mellitus. First of all, we have the study object said that projects object said that we are comparing the data, we are finding the classification, we are finding the classification by using automated machine learning. So we need to study machine learning, deep learning and auto machine learning. Then now what, when we are working on this model, we are working on diabetes. So second thing is that we know that what is the diabetes and its a type, diabetes mellitus. Now, a metabolic disorder characterized by high blood sugar level over a prolonged period resulting from inadequate insulin production or cells ineffective response to insulin. This is the cause of the diabetes, means that what is diabetes? High blood sugar. This high blood sugar can be affect to transport the proper glucose in pancreas, affect proper glucose in pancreas, so insulin can affect. Then this insulin, means that diabetes mellitus is a long term health condition where the body has high blood sugar level. Then due to either insufficient insulin production or the body's inability to use insulin properly. These 2 points. First point is that due to high blood sugar level, due to either insufficient blood sugar. First this, and second is insufficient blood sugar, and second is not inability to use insulin properly. These two types. Now, this diabetes is classified according to working of insulin, how to proper transport the insulin glucose in a pancreas. So the type 1 diabetes is said that the body does not produce insulin. This is then type 1, means that type 1, also known insulin dependent diabetes mellitus, are immature onset diabetes, is responsible for between 5 and 10% of all cases of diabetes mellitus. And types of diabetes that have been diagnosed: autoimmune, genetic and environmental factor are the primary contributor to the decreased prevalence of risk factor for type 1 diabetes. In young people, adult, the development of type 1 diabetes is more likely to occur, means that your immune system is weak, then you can have a diabetic 1. Then now diabetes mellitus type 2. In this type, the body does not use insulin properly. Insulin resistance, means that this is the form of diabetes that develop in adult and can affect people of any age, including children. However, it is most commonly found in a person who are middle aged or older. There is correlation between type 2 diabetes and people who are overweight and inactive because of a condition known as insulin resistance, which happen when fat, muscle and liver cells do not have enough insulin to transport glucose into the cells of the body as a source of energy. It is the primary cause of this disorder. In order to facilitate the transport of glucose into the cell of the body, the pancreas must produce a greater quantity of insulin. That is requirement. In the event that the level of sugar in the blood rise, the pancreas will not make enough insulin and the patient will require treatment for type 2 diabetes mellitus. Now, third type of diabetes, Alzheimer's related diabetes. Whenever type 3 diabetes is not an official recognized type but is used to describe the link between insulin resistance in the brain and Alzheimer's disease. It suggested that poor insulin function in the brain can lead to memory loss and cognitive decline similar to dementia. Now, the main we can say fourth type, or we can say if third type is not the official recognized type, then we can say fourth type also we can say, and the third type. Third type of diabetes is gestational diabetes, developed during pregnancy and usually goes away after childbirth. Means that this is the fourth type of we can say this is the type 4 diabetes, or we can say this is the officially recognized type 3 diabetes. Onset or initial detection of gestational diabetes occur during pregnancy. Gestational diabetes is characterized by a lack of carbohydrates, which leads to hyperglycemia of varying severity. In addition, it does not rule out the potential that the glucose intolerance may have existed before to pregnancy but had not been noticed up until this point. It is irrelevant whether insulin is used for treatment or whether the condition continues after pregnancy. The definition is applicable regardless of either of these type of factor. Now, the fourth type, or we can say the third type, if left untreated, diabetes can lead to complications such as heart disease, kidney problems and nerves damage. But in the we can say the fourth type of diabetes also insulin resistance that occur due to aging. When age is increased, then the diabetes means that the resistance of the insulin will occur. So this type we can categorize in aging issue. When you are in 60, 65, 70, after the 60 years, automatically body parts and pancreas and insulin capacity is also decrease day by day. So this category is also in type 4 we can say. Or any operation, any surgery time, if you find the symptoms of the sugar, or your sugar is high in blood sugar, then when the surgery is happen, then after the surgery you can recover this type. So no need to long medicine or long recovery period. This is the also the fourth category diabetes. Now, review of literature. I have many reviews, many papers review. Most helping the paper Reduc et al. 2024 highlight the challenges of AutoML and Intelligence Discovery Assistant IDS in a data science pipelines, including high computational cost, limit task support and reliance on fixed evaluation metrics. They proposed a human in the loop approach that leverages past pipeline to generate optimized pipeline recommendation based on user query. Main issue in that high computational cost, limit task support and fixed evaluation metrics. Now, proposed solution, a human in the loop approach where past machine learning pipeline are used to recommend optimized solution based on user query. Now, second one is the handling data drift in online learning. This is the Selic at 2022 paper published system to handle data drift in dynamic environment. Their approach optimized online learning pipeline using asynchronous genetic programming and successive having. Experiments show that online automated machine learning adapt better to changing data distribution compared to existing online learning method. Now, Posoldova 2020 discussed the growing interest in machine learning. This is the machine learning and artificial intelligence are powerful tool for predicting outcome based on data. Common application include text prediction, sentiment analysis and recommendation system. Then misconception that many people think ML is a black box that magically find the solution, but in reality it works by identifying pattern in data and applying learned rule. Now this paper also studied by me, the Zondoi Automated Machine Learning 2020. This paper explored the application of AutoML in healthcare, focusing on disease prediction and patient management. Now, second is Jane Smith Deep Learning of Diabetes Prediction. The study in this paper is published in 2021. The study discussed the implementation of deep learning algorithm to predict diabetes with high accuracy. Alice Johnson AI technique for medical diagnosis 2022, a review of various AI based technique used in the effectiveness. Now, Robert Brown machine learning model for disease classification 2023, a comparison of different machine learning model in classifying various disease, emphasizing accuracy and computational efficiency. Emily Davis neural network in medical imaging 2024 explores the use of neural network in medical imaging of early disease detection and treatment planning. Now, Castellanon Neves diagnosis and Gracia Fort Lewis 2023 automated machine learning simplify the design and optimization of ML model, which I also discussed in the first literature review, secondary literature review. Now, these three paper have many help, and Zargar Ovsis 2000 deep learning for early detection of diabetes. This paper give the achievement a remarkable accuracy 97.19, proving its efficacy in medical diagnosis. Redu UK we have already discussed. Cruz Henans, these three paper we have already discussed in a first slide. Now, the research gap. Despite progress in using machine learning and DL for diabetes classification, several gaps persist. There is a lack of comparative study between traditional machine learning model and automated machine learning model in healthcare. Most researchers focus on binary classification rather than distinguishing diabetes type 1, 2 and gestational, posing data and feature selection challenges. Model interpretability remain a concern, limiting clinic adoption due to their black box nature. Additionally, existing dataset, lag size, diversity and real world applicability affecting model generalization. Addressing this gap is crucial for developing accurate, reliable and interpretable model for diabetes detection and management. Now, the limitations is also available: difficulty in understanding model prediction, black box problem. I also discussed that. People said this machine learning is a black box and happen anything in as a miracle, but not the right reality is different, because machine learning model we have to choose the machine learning model, and many of the machine learning model in automated machine learning also choose the best machine learning model to predict the diagnose the diabetes. So, and type classification also I discussed. Type of classification of diabetes is also in the lack of the knowledge and lack of the focuses on the classification of diabetes, because the 50 to 60% people have a high sugar in a blood, but they don't know which type of diabetic he have. Now, research methodology. Now, this is the most and important point of my research. The research design for this study is applied research, which is characterized by its focus on solving practical problems and generating actionable insight that can directly impact a real world scenario. Applied research aim to address specific issues or challenges faced by practitioner in particular field, as opposed to basic research which seeks to expand theoretical knowledge. Now, in this context, the applied research design will investigate the effectiveness of various diabetes treatment strategy from the perspective of experienced physician and medical practitioners. By focusing on practical application, this research intend to provide valuable recommendation that can enhance diabetes management and treatment protocols. Now, in this case, the research will examine different diabetic treatment strategy based on insight from experienced physician. The goal is to provide a recommendation that can enhance diabetes management and treatment protocol. Now, the sample technique, the study uses a non-probability quota sample method. This means that instead of randomly selecting participants, the researcher choose them based on a specific criteria. For this study, physician and medical practitioner with 5 to 10 years or more experience in diabetes management will be selected. This ensure that the study captures a diverse range of expert opinion on diabetes treatment. Now, proposed approach. What is the proposed approach? Now, I have the study collect secondary data from reference, the internet and medical researchers publications. After analyzing the data and getting expert recommendation, a specific rule are created for the machine learning model. These rules are stored in the CSV file, which serve as the data set for the machine learning model. The machine learning model runs on Google Colab, a cloud-based platform that allows efficient execution of machine learning algorithm. The dataset consists of numerical data on diabetic symptoms, helping the system predict different type of diabetes. Now, proposed tools and models we have used. I have also discussed the Google collaboratory image classification using the Fast AI library. The study uses Fast AI, a powerful AI library that helps programmers build ML model with fewer lines of code. Fast AI is built on PyTorch, a widely used deep learning framework. This is then a deep learning framework. This research focuses on image classification, specifically training a computer to detect diabetic retinopathy, diabetic related eye disease using the Kaggle diabetic retinopathy detection datasets. Now, the Google collaboratory online, this is the online coding platform. You can write run Python code in your web browser. Now, setup needed, no setup needed, no need to install Python or any libraries. Everything runs on Google's cloud. Free GPU and TPU. Google provides free access of GPUs for AI ML tasks. Easy collaboration, just like Google Doc. You can share notebook with others and work together in a real time. Access to Google Drive, you can easily save and load file from Google Drive. Now, how to use Google Colab? This is most important, because if we don't learn how to operate and how to use the model and how to use the test models, means that we can say approaches, we can say tools. if we can't use effectively, then we can definitely it can be effect on your whole work. So how to use Google Colab? Go to Google Colab, click new notebook to create new project, write Python code in the provided cells and press shift plus enter to run. Install additional library if needed using pip install. Then this syntax will require to get the library. Save your work directly to Google Drive. Now proposed tool and models in this category: CAN using fast AI. CAN, convolutional neural network, is the type of deep learning. Now we have discussed the previous slide for the ML, machine learning. Now we are discussing the tool for the deep learning, convolutional neural network. When we use the word neural, means that it is the connected with the deep learning. So is type of deep learning model used mainly for image classification, object detection and image recognition. Now a CAN is a type of deep learning model. Then fast AI is a Python library that makes it easy to build and train deep learning models, especially when CNS with minimal code. Means that the researcher or creator who create the model, they don't need to many lines code or any complications in the code. Minimal code it requires. How can CAN works? Take an image as an input, any of the image, means that the figure shows CAN for diabetic retina and normal retina. This image shows that diabetic and non-diabetic both retina we required. So how to compare non-diabetic and diabetic retina, means that sometimes we need to maximum pooling, completion, non-linearity, and that non-diabetic retina will directly pull up. Take an image, extract important feature using convolution layer, recognizes pattern like edges, shapes or textures, classifies the image based on learned features. Now CAN using fast AI. Why use fast AI? Fast AI, it is required because it is easy to use. Just means that we can say this have easy to use and pre-trained model. Uses a model like ResNet, means that reset net to give better accuracy. Automated optimization handles learning rate and training efficiently. Then works with PyTorch, built on top of PyTorch for deep learning key steps in code. Now how to use this? Download datasets, uses fast AI built-in dataset loader, prepare data, load image and create labels automatically. That happened automatically. Then train CAN model, uses ResNet 34, a powerful pre-trained model. Then make prediction, test the model on new image. Now one image is completed. Now you can go with the next image, second image, third image, fourth image. One by one images you can give new images. Then pattern will automatically experience the older image, then predict and then give the result. Now testing model, this is the testing model. Then in the testing model, developing an ML model for diabetic detection is the primarily focus of this research. Major challenges for rule execution and implementation is acquiring the correct user or diabetic symptoms, a person's status as a diabetic patient, as well as the kind of diabetes, type 1, type 2 or gestational, is determined by these combinations of information. We put our machine learning model through its paces with 180 patients. When it comes to physician, it has gotten the job done. Now In order to swiftly and successfully detect different form of diabetes, researchers have developed a machine learning model in developing nations where medical professionals are in a short supply. This aids patients. Less reliance on medical professional is the goal of this smart machine learning model. Decision may be made more quickly and accurately by both physicians and patient with its support. Now, understanding diabetes, its prediction using AI. Now, final result of this study, I am concluded. I am giving the result one by one. First of thing, we have to see this slide. This slide is most important slide of the result. Understanding diabetes and its prediction using AI. Diabetes mellitus, commonly known as diabetes, is a widespread health issue. We also discussed about that. It is essential to develop a system that can accurately detect diabetes and its different type as early as possible. In this study, we introduce a machine learning model MLM to improve the accuracy and efficiency of diabetes prediction. Now, one of the serious complication of diabetes is diabetic retinopathy, a condition that affects the eyes and can lead to vision problem. To detect this condition, we use a convolutional neural network CAN type of deep learning model. The CAN model was tested using a dataset containing eye images with and without diabetic retinopathy. The model accuracy was measured to check how well it can predict the disease. This research show that AI based model can help in early diagnosis and better management of diabetes, making healthcare more efficient. Now, we have prepared the data set in the table format. All will work on a numbering, family history. Now, if type 1 is 0, means that 0, 1 and this number is not the actual age or actual numbers. This is the coding number. Family history, type 1 diabetes 0, type 2 diabetes 1 member 1 and gestational 0. Now, age 11, 12 and 12. This is the scale factor of the aging. Obesity 22, 23 and 21. Previous IFG, IGT, hypertension 0, 5, 5. This is the coding of the hypertension. HDL cholesterol 0, 3 and 0. Triglyceride 0, 5 and 0. Increased thirst 1, 1 and 0. Increased urine type 1, 1. Type 2 1 and gestational diabetes 0. Now, this type of all the weight variation, impaired vision, tiredness, impatient, infection, itchy skin, depression state, tingling sensation, fruity breath odor, bed wetting, then slow healing wound, family his pregnancy and previous pregnancy, baby over 9 PD prepage, sleeplessness, trembling, sweating, anxiety, confusion, weakness, mood swing, nausea, vomiting, dry skin, HSN, pains, recurrent fungal infection, nightmares, seizures, sadness, unconsciousness, numbness, vaginal mycotic infection, rapid heartbeat, recurring gum impotency, high blood pressure, sleepwalking, massage, unusual noises, leg cramps, slurred speech, flushed face, pale skin, loss of masturbation, stomach pain, deep breathing, area dark skin, difficult concentrating, dehydration, lack of coordination, his heart stroke, polyuria, low blood sugar, waist size 0.2 centimeter m 88 cmf, waist hip ratio 9m 85f, means that this is the all criteria we have taken. And after the number presentation of symptoms, Boolean value symptoms and multi-value symptoms. Now, the single person have a family history, true and false. That will work 1 for true and 0 for false. Now, the age young 11, adult 12 and old 13, means that this is the I have said that this is the code. So, Now the obesity low 21, normal 22 and obese 23. Triglyceride normal 2, borderline 3 and high for 4. Now this is the then 4 hypertension normal 3, elevated 4, high 5 and very high 6. Then HDL cholesterol very high 5, low 1, medium 2 and high 3. This is the coding of the number we have coded for the machine learning model, because machine learning model understood by the numbers. Machine learning model. Now we are discussing on the machine learning model. The most effective and methodical approach to multi-class classification is to use decision tree classifier. This job description uses the dataset to do queries. Decision tree, what can do the decision tree? Decision tree categorization may be best representation by a binary tree. Each level of decision tree involves pausing inquiry and subsequent node separation based on information with distinct attributes. The depart node is referencing the class to which it belongs whenever dataset is divided or split. To train the decision tree classifier from skit-learn, researcher used to the following code. We employ the class decision tree classifier, which has greater capacity and performance ability for the multi-class classification of the dataset. Now, how it can work the machine learning? It recognizes data into binary tree structure, where each label is split data based on different attribute. The tree asks a question at each step and separate the data into different branches. The final node means that we can say leaf node assign a class label to data. Implementation, the skit-learn library provide a decision tree classifier for training. This classifier is efficient and provide good classification performance for complex dataset. Now, the proposed datasheet. Proposed datasheet is said that here is a datasheet containing value that make up the expert system, knowledge base and rules. A machine learning based expert systems knowledge base consists of the following rules inserted into the dataset. CSV file, all will given to the machine learning model on Google Colab. I also said that that Google Colab directly use and send the data to the machine learning model, with each rule appearing as a row in a table. Now, this is the dataset. This format is also CSV file. Dataset contain value and rules, knowledge base value and rules. Now, a decision tree classifier is used for multi-class classification and data into smaller group based on attributes. The dataset is stored as a CSV file only and serve as the knowledge base for training the expert system. Now, library data import. This is the library data import. These pandas as a PD, netplot library, pilot as a PLT, sklearn and df equal to PD. This is then output of the importing library and dataset. Now, the library dataset import and preparation, load the dataset and stored label in a variable. Label is most important thing. We have to given the label. Used df.head to view the first few rows and df.shape to check row column count. Now, data splitting, train and test set, train and test set. Sort data into training and testing set based on label and attributes, because complete testing will happen when label is correct. So, label is most important, and attributes means that input which we are giving. Use train underscore test underscore split bracket close from skit-learn to divide the dataset randomly. Model training and prediction. This is the train the model using the decision tree classifier. Use the predict bracket close function to test and generate output. Overfitting issue and solution. Overfitting can occur while creating the knowledge base. Knowledge base, when we combine or maybe superimpose the any similar type of data can occur while creating the knowledge base. To fix this, apply the right optimization method and test different solution. Now we have option to test different solution in machine learning model. Now final result and discussion at that point. The machine learning model was tested in 150 diabetic patient for validation. Out of 180 test cases, the model achieved a 94% accuracy. It predicts diabetic type using D3 underscore model dot predict bracket close based on patient symptoms. The algorithm analyzes symptoms from a data set to provide recommendation. 5 test cases were verified using data from 5 selected patients. The model helps identify diabetes type based on input symptoms. A literature review compare this system with existing diagnostic model and expert the system. Now, predictive study play a crucial role in medicine, pharmacology, social and healthcare. Machine learning has significant potential in diagnosing diabetic complications like retinopathy and neuropathy. Continuous research aim to enhance, because I read the first paper in 2013 to 2020. Then 2020 paper, they have no model to automated model, but in 24 I have studied in 24 paper. I have also discussed in literature review. The paper said that 97%, but this study gives the 94% accuracy on 150 individual data. But this the 97% is not the categorized type of diabetes, but we have also include the category of the diabetes, types of the diabetes, in the patient is in which condition and which type of diabetes he have. So 94% accuracy comparable to human doctor. Future improvement in data collection and AI advancement can further enhance prediction accuracy and early diagnosis of diabetes. Now, reasoning with certainty factor. One of the most important factor we have to diagnose, we have to uncertainty is the common challenge in real life and decision making. In healthcare and AI, we use a concept called the certainty factor, CF, to improve prediction and diagnosis of disease like diabetes. Now, we understood what is the certainty factor. Certainty factor tells us the probability or confidence level that sometime is true. It helps in making more accurate prediction in uncertain situation. Now, why is CF important in healthcare? Medical conditions are often complex and uncertain. So, CF helps in analyzing symptoms more accurately for better diagnosis. How does CF work in diabetes prediction? When creating a data set for machine learning model, the patient's belief level about their symptoms is included as a CF. This help in fine tuning prediction by considering how certain a patient is about their symptoms. How is CF certainty factor applied in AI and machine learning? AI model use certainty factor based reasoning to weight evidence before making a decision. It improves accuracy and reliability in disease diagnosis. Benefit of using certainty factor in healthcare: reduces misdiagnosed by considering certain symptoms, enhance AI decision making by adding human like reasoning, improves prediction model for disease like diabetes, heart disease, AIDS. By using CF certainty factor in AI healthcare system, we can increase accuracy, improve patient diagnosis and support doctors in a decision making. Doctor, which type of solutions doctors need to give, this can also help to doctor's decision. Patient where, now the certainty factor for machine learning model, this is B. The patient were asked to write their certainty factor for each symptoms during data collection based on their view about that symptoms, while the value of CF determine the range of value for the certainty factor, which may be anywhere from -1 to 1. This is the range of the certainty factor, -1 to 1. Certain symptoms have a binary value that can only be expressed as a 0 or 1. Values that do not apply. Columns represent A type 2 diabetes, B type 1 diabetes, and CFA means that certainty factor for type 2 diabetes, and CFB certainty factor for type 1 diabetes. The model discover or predicts the diabetes class that the user or patient is following in relation to the symptoms they have picked, with the goal of finding the symptoms that fit them the most closely. Column representation, I have also told that. Now the model discover predicts the diabetes. Now this is the table. I have also CF number, CF8, CF9, CF10, symptoms, increase thirst A for the certainty factor of type 2, and 0.95 B1, then A is correct, A for type 2 diabetes and B for type 1 diabetes. Now increase urinal 1 for true, and if this can be 0, then that will be false. Then CF10, CF8, CF9, CF10, as well we have taken the data CF1 to CF10. This model predict that the patient is suffering from type 2 diabetes based on symptom number 8 CF8 0.95 and symptom number 9 CF9 0.95. Therefore, a high CF value is required for type 2 diabetes. Now table for prediction, this table is we have referred. The researcher has verified that the provided prognosis is accurate for all 50 cases. The certainty factor in an expert system that relies on machine learning are very valuable, but they are only appreciated after the system has performed its expert duty. Now certainty factor machine learning model, this diagram shows the decision tree for binary 0 or 1 value of symptoms prediction of diabetes type. Now this tree goes symptoms value 0 or 1, 0 for false and 1 for true. Symptoms value 0 for false and 1 for true. Symptoms value 3 symptoms value we required. Then if symptoms 1, symptoms value 0 or 1s, both are that. If this is the 1, then return to parent node type 1 diabetes. Good for that. Now this is the symptom 2, this type of decision making type 2 diabetes. For symptom 3, this is the different type of symptoms value based on the table given on the previously in previous slide in result section. Now this is the certainty machine learning model that can create now prediction of diabetes type symptoms. This is the model for the machine learning. Symptom as a CF value, symptom as a CF value, and previous tree is the without CF value. So this is the without CF value, this is the symptoms. Then we categorized in the CF value as a CF value we can decide type 1 diabetes, type 2 diabetes or gestational diabetes. Now certainty factor is work as a measure of their conviction in the severity of their symptoms. Patients are asked to record their certainty factor. The decision tree method build the tree based on this confidence factor data, which is determined using the criteria of -1 to 1. These characteristics represent the knowledge gain instead of using binary 0 1 symptoms value for classification, as in figure 1 shows, and show figure 2 the decision tree uses certainty factor to improve the categorization. So this is the importance of the certainty factor. We have used both the tree. First is without certainty factor and second is with certainty factor. Certainty factor improve the categorization. Researchers have developed a novel method that integrate AI expert system with machine learning Here we will classify diabetes kind using basic decision tree method, a non-parametric supervised learning technique in order to comprehend and construct the rule of the system. This model uses the symptom stored in the dataset as a row as a rule. The model then uses these symptoms to forecast the class of diabetes. You may further improve the processing and prediction accuracy by including certainty factor approaches into your machine learning platform. Turning expert system into machine learning platform is as easy as following this generalized strategy. More precise healthcare forecasting are possible with consistent and high quality research. Now, deep learning model for prediction of diabetic retinopathy. First one is the category classification of diabetes, type 2, type 1, type 2 and type 3. Now, deep learning model will work to find the diabetic retinopathy. The most common diabetic consequences is the conditions impact on the eyes. Just as 30% of all diabetic have impaired vision, 30% of all diabetics show symptoms of retinopathy. Also, the number is going up. By 2040, these figures are expected to have risen substantially. Serious health consequences are more likely in those with the diabetes mellitus. These complications of diabetes may be categorized as either macro or microvascular, specifically when damage occurs to both macro bigger and micro smaller blood vessels. Damage to blood vessels causes kidney failure. Damage to the eye causes poor vision, means that damage to a blood vessel, nephropathy causes kidney failure. Damage to the eye, retinopathy, cause poor vision, and damage to the nervous system, neuropathy, causes improper functioning. Now, the artificial intelligence have already shown promise in a number of healthcare applications due to their ability to execute complicated tasks for image diagnosis. The most prominent uses of AI in healthcare has striking similarity to ophthalmology. There are a plethora of benefit to using AI in healthcare. In most cases, an ophthalmologist is the best person to handle the challenges that arise from using artificial intelligence. If professionals want to be in a charge of their careers in the future, they need to be able to use, evaluate and apply deep learning effectively. This requires knowledge of intelligence, algorithm and self-education. This is useful for practitioner because it allows them to use efficient algorithm trained on picture dataset using basic image notice and prediction structure to cut down on investigation and human error. Now, this is the major complications in a retina. AI, ML and deep learning may identify disease specific pattern and link novel structure to enhance novel scientific understanding. It is said that hyperglycemia is the primary symptom of diabetes. Now, preventing problem caused by elevated sugar level is a major concern. Both macrovascular and microvascular complications may arise from diabetes. Figure illustrate the most significant diabetic consequences: high blood pressure, now heart attack, brain stroke, kidney failure, nerve damage. This is the different type of, then blindness. This the major complications, retinopathy. Now, proposed work on the retinopathy. Step 1, download image data. Various datasets may be loaded with the library FastAI. Additionally, it may extract image from document by referencing their URLs or other online resource to access the datasets. Image file hosted on their own server, you need to know their URL. Now, load and view data. One of the objects in a library FastAI is useful for training the proposed framework using data bunches. To load the data sets, this object was created using the image data bunch from folder function, which is directly connected to problem. Now, solving method is that create and train a model. Now, epoch train iOS, this is the code we have to create the table. Proposed work result. Now, create and train a model. First, we need to train the model. This is the main important work on machine learning. Machine learning and deep learning also require the training. So when we train that the machine learning model or a deep learning model, that can be worked on according to prediction and according to data available and experience uses. The fast AI offer learner with the library that helps them create and produce framework with reduced amount of programming line. The development of a convolutional neural network is the responsibility of the create CAN function with the weights set to data set. This model follow the ResNet 34 architecture. This is the architecture of fast AI which can be offered. Layer at the very top, which are totally coupled, get the training. When training the framework picture database, the method fit one cycle. Now one cycle, then was used. One way to apply the constant rate of learning is by using the fit. Now the function fit one cycle is used to get the optimal output by following the single cycle rule and fundamentally changing the pace of learning, which shows in the figure. Now cleaning the data. Now fourth step is cleaning the data. The library fast AI provide the capability needed to accomplish the goal of data cleaning using the Jupyter platform. Image may be renamed and removed using the image cleaner. The syntax of the cleaner bracket close function. The researcher working on image cleaner retrieved the incorrectly categorized top loss photo using the dataset formatter, then from top loss method. Now this is the syntax to remove the data, clean the data, update the data, and image cleaner retrieve the data. Incorrectly data can correct, you can correct. Now interpretation, this is the final result of proposed work. The class classification interpretation is used its function to interpret the result at the conclusion of this framework building. The learner framework provide accurate prediction by invoking the method from learner and sending it on. Now prediction of category normal retina versus diabetic retina. This is the normal retina and this is the diabetic retina. Prediction by invoking method from learner and send. Now you can see in the image. Now accuracy model researcher define specify for these two class issues, confusion matrix, non-diabetic and diabetic. Diabetic is a 72 and non-diabetic is a diabetic and non-diabetic. Diabetic and non prediction level, that is the prediction level. Now 98 diabetic and non-diabetic. Non-diabetic 256 and non-diabetics 272 levels. That is correct prediction confusion matrix. Then picture accurately recognized as diabetic retina, diabretina, or normal retina, normal retina. Now accuracy is defined by researcher as the percentage of test pictures correctly classified. With 80% accuracy, the final trained network was success. If you want a higher level of accuracy, you will need a larger data set, and fast AI CAN can handle a larger number of test photos with ease. Quick prediction and responses are produced by this trained convolutional neural network. Now final result of that retinopathy, researcher used the number of properly recognized picture as a diabetic retina, diabretina, or normal retina to determine a specificity for these two class problem. Accuracy is defined by researcher in term of retinal picture that have been correctly classified. The final network design and had an accuracy rate of 80%. Any number of image may be classified using the FastEye library. Quick prediction and instant responses are produced by the trained convolutional neural network. Now some of the test cases that the researcher has provided as follows. Make a guess as to the picture classification for which we trained the model. Virtual computers equipped with a graphic processing unit capable of more than 960 teraflop of execution per event are available via Google Cloud Service. V100, P4, P100, Tesla K10, NVIDIA and T4 GPU bring DL molecular modeling and simulation to life. obtaining a flawless GPU graphical users interface then is possible for everyone regardless of the scope of the extraordinary task at hand. Now, the use of deep learning technique in the medical field, which are based on image processing, illness detection and assessment. Now, this is the purpose of the research study is to propose a model for diagnosis of diabetic retinopathy using fast AI. The model would make use of the fast AI library and would need less code in order to get better result. Now, in term of the image processing model, this convolution neural network will work model is effective since it's a trend utilized GPU system that is offered by Google Colab. A speedy and correct result may be obtained with the assistance of the neural network that has been pre-compiled. This model that has been suggested is able to differentiate between photograph of diabetic retinopathy and photo of normal retina. The detection of all phases of diabetic retinopathy may be possible in the future with the development of modified model that utilize a bigger data set as a mean of providing ophthalmologists with support in healthcare diagnosis. This CNN is available. Now, the conclusion of this research insight and impact demonstrated the effectiveness of AutoML and deep learning in medical diagnostics, showcase the transformative potential of these techniques in diabetes classification. Now, the objective and model development is also occurred aimed to develop a robust and reliable model for diabetic classification, utilize AutoML for automated model selection, hyperparameter tuning and featuring engineering, integrated deep learning technique to capture complex data pattern. Now, deep learning techniques use employed convolutional neural network and recurrent neural network RNN enable feature extraction from high dimensional data for precise classification. Key finding: AutoML streamline model creation, making machine learning accessible to varied expertise level. Combination of AutoML and deep learning significantly improve classification accuracy, reduction human effort and time for manual tweaking and validation. Clinical significance of that study is ensure quick and accurate diagnosis vital for clinical applications, promoted early disease detection, personalized treatment and better patient outcome, highlighted the potential of AI driven diagnosis tool for informed medical decision. Now, challenge and limitation: need for high quality well labeled data set, high computational requirement for training deep learning model. Deep learning model is a complex model. I face the many challenges to how to train the deep learning model. So this is the high computational requirement. So model interpretability remain a challenge. Final conclusion of this study demonstrated the powerful combination of AutoML and deep learning in diabetes diagnosis contributed to the growing field of AI in healthcare, paving the way for future advancement, emphasize the need for continued research and technology improvement. Now, recommendation of the study: enhance data quality and diversity, optimize model interpretability, develop resource efficient model implementation, implement real world testing and validation, address ethical and privacy concerns. Now, I will discuss one by one. Enhance data quality and diversity. This is the set of the utilize high quality, diverse and well labeled data sets. I also discussed in a last slide from the conclusion. This is the main requirement: well labeled data set. If label are well maintained, well corrected, then your result will be definitely impact on this label. Awareness is the impact on your final result. Collect data from various demographic and locations. Collaborate with healthcare organization for access to large representative data sets. Now, optimize model interpretability, improve clarity and usability of deep learning models for doctors. Explore feature significance analyzing analysis, visualization tool and model agnostic methods, develop resource efficient models, reduce computational requirement for broader adoption, use techniques like model pruning, quantization and efficient network architecture, implement real world testing and validation, conduct clinical trials and pilot study to evaluate real world performance. This is the only study. Now we can go for the next level of this research, implement the real time performance, evaluate real time performance, gather feedback from healthcare professionals on usability. Definitely it will work to improve the accuracy and training of the model, address ethical and privacy concern, ensure strict data confidentially and compliances with the privacy laws, mitigate AI bias to ensure fair and ethical decision making. Now suggestion of the study. Now this is the recommendation of a study and suggestion for of the study. Advanced model architecture to enhance the effectiveness and real world applicability of the proposed AutoML and deep learning based diabetic classification model. The following key recommendations are suggested. Advanced model architecture, explore transformer based and hybrid model to improve classification accuracy, domain specification integration, incorporate expert insights from endocrinology for better feature selection and validation, enhance data pre-processing, implement advanced technique for handling missing value, outlier and data normalization, real-time data processing, develop a framework for real-time diabetes prediction to support dynamic clinical decision making, multimodal data integration, combine genetic, wearable and electronic health record, EHR data for comprehensive diagnosis, diverse population testing, ensure fairness and generalizability by validating across various demographic groups, user-friendly interface, design intuitive interfaces with visualization and decision support tool for clinical adoption. These enhancements aim to refine the model, boost its clinical utility and contribute to AI-driven advancement in diabetes diagnosis and management. Now this is the reference I have also said in the, I have also discussed in the literature review. This is the bibliography. Now thank you very much for listening the whole study and I am very grateful to hear and I am very grateful, I am feeling very grateful to my guide Dr. Rao. So thank you very much all dignitaries and all the faculty members, HODs and all the here my presentation, all those present to hear my presentation. Thank you very much. This is the my research work I have totally summarized by this presentation. Thank you very much. Thank you.